So, my name is Adam Kennard. This is a lecture titled How to Get Started in Combat Robotics. So, first off, just a little bit about me. As I said, my name is Adam Kennard. I am a junior technology and education major here at TCNJ. I've been competing in combat robotics since 2014. It'll actually be 10 years this coming June or July, I forget. And I've built robots that weigh from 150 grams to 12 pounds so far. So before I get started, just a little disclaimer. I don't know how long this presentation is going to take me. So it might be a little short, might be a little long. We'll play it by ear. Worst case scenario, I'll just give you the Cliff Notes version. So what is combat robotics? So these are remote controlled for the most part, wheeled robots. There are some robots that have a coding and AI element to them. However, they're not really seen for the most part, especially in these lighter weight classes. They have timed matches. So usually it's about 2 minutes to 3 minute matches per event. They either end in a knockout, tap out, or a judge's decision. There's double elimination brackets, so even if most competitions run the double elimination bracket, there are a few that do like a slight variation of it, but it's nothing too major. That the main point is they want to give you at least 2 fights. That way, if something doesn't really go your way the first fight or something breaks that shouldn't, you still have another fight at least to try to get that squared away. There's a whole bunch of different weight classes. Obviously, you guys probably seen the ones on TV. Those are a lot more heavy than what the normal hobbyists can afford. So that is what I'll be focusing on today. Then just there's different strategies and methods of attack. So that leads us right into what are these methods of attack that these robots can go against each other. So the most basic one is just a simple wedge, an inclined plane. The thought behind the wedge is basically just to get under and control your opponent while also aiming the energy of any spinning opponent that spinning weapon that an opponent might have back at their opponent. So Newton's law, every action has an equal and opposite reaction. So any kind of spinner, anytime it gets a hit on the robot itself is also taking that shock. So that's what the wedges normally do. It's one of, if not the easiest to build, just because you just put an angle on it and then you're basically good to go. Most armor of any type, because you don't have to worry about any spinner motors, spinning masses, anything like that. It's often paired with other weapon types. So you'll see if you have like some of the later weapon types, you won't just see that type. It'll also be paired with like a wedge, just as like an added defense system. But I guess the most common thing though is that it's very easy to start with a wedge robot, but to have an extremely good wedge robot, it's extremely difficult to master, because if you think about it, there's no way to score offensive points. We'll get into judging a little bit later, but it's basically if you take damage, that's points for the other opponent, and but there's no way of you being able to dish that directly to the opponent. So the next kind is the lifter, kind of a variation of the wedge. It allows you, it's the simplest active weapon type. So there are a couple competitions across the Northeast and across America that have a active weapon rules requirement. So you have to have some sort of moving mechanism aimed to score points against your opponent. So it's very, again, very simple designs usually. usually paired with wedges, as you can see here. Sometimes they're just forks. The main goal of the wedge is to be able to lift the opponent up. That way you can control them more in the box and assert domination that way. It's very useful if you want to just learn how to drive in matches. It's very useful for that because you have to learn how to move precisely. That way you can engage your lifter without it getting damaged, since it is very easily damaged. It's any kind of thing that has a joint like the lifter has is very easy to damage in this sport. But the thing is, it can be difficult to win judges' decisions. Same thing with the wedge. You don't really have that offensive element to this robot to be able to score damage points. And damage points is the most heavily weighed category in a judge's decision. So with those two out of the way, that brings us to vertical spinners. So these are the most common weapon type. It's the most entertaining because if you ever see videos of them working, you always see the robots flying up in the air and whatever like that. That's because the vertical spinners, again, Newton's law, every action equal an opposite reaction. Since it's spinning up, the force that's exerted onto the robot drives itself into the floor as opposed to away from the opponent, and then the force into the opponent just goes straight up. So you're able to fling them further up more reliably than others. It is complementary with multiple other attack types. So wedges, lifters. It's very easy to do one and the other. And then there are also like multiple variations of the vertical spinner. So you have some that are like extremely narrow. You have extremely narrow, like the one bottom middle there. You have extremely wide. And then you also have like middle of the way, like two discs with like a little spacer in between. So a lot of variation. Yeah, it works because it's effective. So the next type is the horizontal spinner. So horizontal spinners are definitely the most difficult to build well. As you'll sense a common theme with these robots, it's easy to start, but it's very hard to master. And that's one of the things I really like about this sport. Out of like all the common weapon types, you'll see, get into a little bit later, different like specialty weapon types that are extremely difficult to build. These four that I've shown you, these are just the most common. You'll see these every event. Everyone in the communities will help you build these and give their tips on what's worked, what hasn't. But the horizontal spinner, however, similar to how the vertical spinner had various widths of the weapon, the horizontal spinner has probably the most like distinctive variation. So like the one top left, that's just a standard like horizontal bar spinning, doing its thing. The one to the far left, that's what's called a ring spinner. It spins horizontally, but the whole shell of the robot is what spins. So it's impossible to attack the robot without getting hit yourself. Of course, there's trade-offs to that. Like if your weapon goes down, you're basically defenseless, but that's another thing. And then there's just various ways you can put that onto a robot. So these are like the specialty weapons I was talking about earlier. Some are just meant to be fun and games. Some are actually extremely effective. So if we look at the top right, might be a little bit hard for people to see, but that's what's known as a hammer saw. So what that is it's an articulating arm with some sort of vertical spinner on it, so that it actually comes down and while it's spinning, digs into the top of the robot, bringing it down on top of it. The one immediately to the bottom left of that hammer saw is what's known as a crusher. Larger robots will use hydraulics, but usually in these lighter weight classes that I'll get to a little bit later, will just use like an extremely high torque gear motor or some form of force exertion like that. To the bottom right of the crusher, we have flamethrower robots. Those are extremely popular, pretty difficult to build. And not all competitions allow it because there's obviously certain safety standards that have to be adhered to in order for the competitions to take place. But the ones that do allow flamethrowers, it's actually been getting kind of scary how effective they've been. Like, oh, you'll see, oh, cool, it's a little fire, until you realize most combat robots, especially on these smaller scales, have 3D printed components. So if you get in there and it gets any kind of pin time and getting direct flame onto that robot, it'll just melt the robot completely. So the bottom of that is actually one of my favorite robots. I talked to the builder personally, and he said he classified it as a pneumatic sportsman 12-pound robot. Like, yes, he's technically correct about that. However, that is an airbag that the robot has as a weapon. So the idea is that it gets under the robot, and then it only has one fire, but one launch capability, but it gets under the robot and it launches the airbag, and it just launches the robot that way. Kind of more of a joke than like an effective weapon type, but I absolutely love it. It's one of my favorites. To the left of that, that is actually a jet engine mounted onto a robot. Kind of like the same philosophy as a flamethrower, just like getting the hot air on the robot. I think someone just really wanted to put a jet engine on a robot. I think that's what happened. It has two little control bots to try to help pin the opposing robot while it gets that direct jet engine on them. And then to the left is just a basic hammer robot. That one I actually extremely love because they printed the hammer head out of a flexible TPU filament, and they put a toy squeaker inside of it. So every time it hits the other robot, you get a squeak, squeak. I love that. So all of these very interesting concepts. These are usually attempted by more engineering majors and like people who are extremely well off in this hobby. They're pretty rare. Like, you'll see a couple of them, but not nearly as many as the previous 4 weapon types. Crushers, hammer saws, anything like that. But then again, because you have so much weight dedicated toward these specialty weapon types, you don't really have that much arm. So it's really a trade-off on what you can do and whatever you can do. So talked about attack types. So now these are the different weight classes that you are able to compete in. So the first class and the lightest class, we just go lightest to heaviest, is called a fairy weight. It weighs 150 grams. At that weight, it's a little bit difficult to design because the parts you need are kind of oversized for like the body you need to put them in. It can be a little bit again, difficult to design. So of course that presents unique design challenges, which means you get unique solutions all the time. Like I built the one in the middle there. I had a couple parts that I really wanted to use. So what I did was I created a shuffling cam mechanism, because with Combat Robotics and Locomotion, I don't have a slide on this, but Locomotion traditional wheeled type robots just get the full, in this case, 150 grams. The accepted weight for any unconventional locomotion, like a cam shuffler mechanism, is you get an extra half of whatever that weight class is. So this is 150 grams, so you would get an extra 75 grams in order to build the robot. So that robot can weigh in at 225 grams and still fight the 150 gram robots. These are a lot of fun to play with, but there's also very few competitions to compete in. A lot of people are more focused on like the slightly heavier robots just because it's a lot easier to get into and so on and so forth. So the next weight class is just your standard ant weight class. These guys weigh in at exactly 1 pound. This is one of, if not the best weight classes to get started in. They're not very difficult to design. Again, as with like the attack types, it's very easy to get started, but as soon as you hone in and try to do exactly what you want to do with the robot, you start running out of weight extremely quickly. But it's a very manageable size. You don't need that big of tools, that big of machinery, or anything to be able to build these. And another thing, they're also extremely affordable. The next one is kind of a offshoot of the full combat ant weight class. These are the plastic ant weight class. This is my personal favorite class to compete in. Again, these guys weigh 1 pound, same as the full combat ants. However, all of these robots must be entirely made of 3D printed plastic. So that includes you're allowed to use hardware, so like bolts, bearings, bushings, whatever you need for that. But however, anything that another robot can be in contact with, armor and body wise, has to be 3D printed material, except for hardware, wheels, other things like that. This is extremely beginner friendly because obviously you can get filament for extremely cheap. And then at that point, you're basically only paying for the electronics, motors, and all that. And since everything's 3D printed plastic, you don't normally take a lot of damage. So you're not replacing those parts as often. And then since everything is plastic and they don't cause as much damage as the full combat, it does encourage different designs. So like this couple slides ago where I showed you the squeaky hammer, that was a plastic ant weight. If you were to do that in a full combat ant weight, probably would have gotten destroyed almost immediately. But that's one of the advantages when you have ant weight class that's fully geared towards these unique designs. The next weight class up is called beetle weight class, weighs 3 pounds. This class 100% has the most competitions to be able to go to nationwide. You go to a competition, any of the smaller competitions, the 3 classes they'll normally have is ant weight, plastic ant, beetle weight. And then there's also, I forget if I have a slide on it later, but there's also it's now the National Havoc Robot League, formerly the Norwalk Havoc Robot League. And they hold competitions probably 6 or 7 times a year, always filled to the brim with robots. I think last year it was the first ever combat robotic competition to have over 200 competitors competing in that event. This weight class also has the most kits, most diverse kits in order to get started. And it's also one of the best classes to get started in. So as I mentioned before, ant weight, plastic ant, and beetle weight. Those are the 3 classes you really want to get started in. A lot of people start with the 3 pound because there is a lot more weight, like the part size to weight ratio is a lot better than some of the other classes like ant weight. So you will have more weight to play around with, whether it be chassis or spinner or anything like that. And this is one of the best classes, one of the most entertaining as well. Next heaviest is hobby weight. So these robots weigh 12 pounds. They are much more expensive than any of the 3 pounders. I would not recommend getting started in this weight class or any of the other heavier weight classes. These robots are extremely explosive for their size. At the National Havoc Robot League, They have cages, I believe they're 30, maybe not 30 feet. Bottom line, they're 10 feet high. You will have these 12-pound robots consistently hitting each other to the ceiling. It is it's a treat to watch. But it is also gaining popularity because people are a lot of the more experienced builders are getting a little bit bored of the 3-pound weight class. So now they're trying to test new waters. And so they're going up to the 12-pound weight class. There's also a lesser known 15-pound weight class. I think it's called Dodge weight or something like that, I believe. That is geared mostly towards colleges and high schools. There's a competition out in Bloomsburg, Pennsylvania. They handle that. They're trying to get it to be more of a national thing, kind of like First Robotics and Vex Robotics. But they're trying to do all they can with that. The next heaviest is 30 pounds, call it featherweight. These are definitely the most expensive robots for like the average hobbyist to be able to afford. Like you see the engineering that goes into these, like a couple of these, like the bottom left, I absolutely love that robot. Wonderful engineering takes place here, along with if you take a look at the top right robot, the horizontal spinner. That one has a shuffler cam mechanism similar to the one I explained before. So now, as opposed to getting an extra 75 grams, this robot gets an extra 15 pounds because it has a shuffler locomotion mechanism. So now that robot is 45 pounds competing against these others that are 30 pounds. You'd be surprised how well it evens out because the shuffler mechanism isn't as reliable as the wheeled mechanism and it takes up more weight. So there's trade-offs that go on there. But there are people that are slowly but surely making it as reliable as possible. So this is the last class. I'm sure if you guys have heard of BattleBots before, this is the weight class that competes on TV. These suckers weigh 250 pounds, which is wild to think about. They are easily, by far, the most expensive robots. I believe I heard someone say, if you don't have $50,000, don't even think about it. So I probably won't even be dreaming about it for a long, long time. So again, these are just like the ones you see on TV. This is probably the most well-known weight class of combat robotics as a whole. There are also light and middle weights. Those aren't nearly as common. I think they're down to maybe one competition a year that runs them. Lightweights are 60 pounds. Middle weights are like 120 pounds. But they're not really as common. They were common back in when the BattleBots show was on Comedy Central back in the 90s and early 2000s. But now, since that kind of died off and the new TV show only runs to 250 pounds, they kind of died out as well. So that's all well and good, right? But what parts do these robots use? How do I actually get started into combat robotics? So the parts I will be showing you guys are specifically for the ant weight class. So whether that's the full combat or the plastic ant, since I believe those are the two of the three best weight classes to get started. So what you're going to need first, regardless of what robot you decide to build, you're going to need a transmitter and receiver. My personal favorite is the FlySky i6. Extremely affordable, like $60 for the transmitter and receiver. However, I do purchase a different receiver than what comes with the transmitter. And that is the FlySky 2A receiver. Extremely small, durable for its size, fits places you need it to be. But however, there are more expensive options available, have really nice trimming mechanisms, and they're worth the money. But if you're just getting started, don't know if you want to actually get into this or not, I would go with the FlySky i6. So battery-wise, these robots run off of small lithium polymer batteries. The voltages and milliamperage needs vary per robot, because some you need a lot more current drawn than others. The robots I use, they're standard 4-wheel drive vertical spinners. I had a couple pictures up of them before, but I use 3-cell, so that's 11.1 volts and 300 milliamp hour lipos, and those usually last me the full 2.5 minute to 3 minutes that is needed for a fight. So all robots are required to have some kind of master turnoff. So whether that's a power link or an Allen key switch, like those pictures, they're all allowed as long as it's easily accessible and it's effective. So you can't, there's no messing around. You can't have robots just coming live, being on outside of the arena. So those are a couple of the options there. Drive motor wise, there are a couple different ones you can choose from. One on the top left, that's an N20, very common. The one on the right is a more specialized motor, actually designed and built by a friend of mine. Those are small planetary gearboxes on that brush motor. And then he also sells kind of a variation of that has a brushless motor, so extremely more fast. If you do want to have, there are a couple trade-offs for brushed and brushless. Like the N20s to the top left, they work. They're also very small, so if you have a robot that you need to shave a couple ounces off, you switch to N20s, you'll be good to go. They work. The brushed on the top right, that is a very mainstay, very simple to use, very good for beginners. The brushless is very powerful. However, I'm personally not quite a fan of them. They don't have quite the fine granular control from the transmitter. And that's just due to like slow startup torque and all that. But there's also size constraints that I already talked about. So as far as the drive ESCs go, obviously you need different speed controllers for brushed and brushless motors. The top two are both brushed speed controllers. The top right, that's just a single. The top left is a double, so you only need one of the top left, but two of the top right. The bottom left one is actually kind of interesting. That is a combination receiver and motor controller. So that could save you some time, some space. And then the bottom right is actually a dual brushless speed controller for those used in drive applications. So how do you get those weapons to spin at the outrageous speeds they do, like 13,000, 20,000 RPM? You get brushless weapon motors. The most common sizes are the 2622, 2822. Again, whatever size you need, depends on the robot. And then if you're also running like a lifter or anything like that, normally servo motors are used. Simple, easy. You already get the standard lift that you do. Some people do use like the previous drive motors. They just put a limiter on them and they use it for that. Then obviously there's the brushless ESCs if you want to go with the spinner route. It's a lot easier to mistakenly choose the wrong brushless ESC for the spinner than it is for drive, because drive, that's normally just staked out, like you know exactly what you want. They're all the same. However, depending on your robot's needs, you could use anywhere from like 20 amp ESC to a 35 amp ESC. And then you could go, if you use too high of an amp ESC, you could run out of battery earlier. So there's a whole lot of considerations that need to be taking place. So as far as wheels and hubs go, they sell I'll have a resource page later in the presentation, but they sell pre-cut EVA foam wheels in like standard sizes. I'm pretty sure they vary like a 1/4 inch each diameter or anything like that. And then they use these special machined twist hubs. You can see they come in 2 pieces, and then you just put them on, press down, and twist them like that. You can also 3D print hubs, very common, but those just work best with those wheels. So here is like just run-of-the-mill combat robot wiring diagram, what you want to do. So you'll see the battery, big red battery, goes through the battery connector. That's where the cutoff switch master turn-off key will be. And then you want power to go to each drive ESC and then to the weapon ESC. That's full power. If needed, if there isn't a battery eliminator circuit on any of the ESCs, that's also very common. You shouldn't normally need a 5-volt BEP for the RC receiver, but it also shows that as well. The ESCs get their signal from the RC receiver, which in turn gets that from the RC joystick. So that's basically what it is. A lot simpler to wire up than people normally think. So that's parts for those who want to design your own robot. But if you're looking to get started, kind of quick plug and play solution, there are multiple kits out on the market. So this first one is the one I would recommend the most. It's called the Viper kit. It's actually made by a company up in Canada, but there are United States resellers if you want to get it quicker. This, in my opinion, is the best starter robot because it's good enough to get a couple wins, even though it's your first competition. However, in order for it to take that next step, you're going to need some heavy modifications. You're going to need to put in some thought to the design process and all that. You will get your wins. You'll just have to work for them. And that is if you're looking to just engage the design engineering process, look at what works, what doesn't. This is the kit that is definitely the most educational. This is the Scalar kit, also made by a friend of mine. It's a horizontal spinner kit, kind of looks like the standard, just run-of-the-mill horizontal spinner. Has a couple ways you can buy it. You can buy it just the frame. You can buy like specific parts for it. You can buy just 3D printed parts for it. You can print the parts yourself. Yeah, there's a couple different options there for you. This is the Necessary Evil kit. This is about as complete of a WedgeBot kit as you can get. It is 4-wheel drive, but 2-motor drive. So it's 2-motor, 4-wheel drive. It has the gears on the output there. Again, we'll need a couple modifications if you want to make the best. So as you can see there, if those gears take any amount of damage whatsoever, they have a chance to jam up, therefore limiting you to one-sided drive. Don't really want that. But very solid starter option. And then this is one of the vertical spinner kits on the market right now called the Baby Nautiloid kit. Just a standard 2-wheel drive vertical spinner. Easy come, easy go, very standard by the way of design. So these are a list of part suppliers. IT Grezza Robotics and Palm Beach Bots, they're more of like a hub where you can get all of the specialized parts in one place. That way you can just order from one place. Repeat Robotics, FingerTech Robotics, and Just Cuz Robotics. They make specific parts. So Repeat Robotics makes the drive motors that I was showing you guys. FingerTech Robotics makes the Viper kit. And Just Cuz Robotics has good materials if you want to start with beetle weights. So how you know what weight class you want to start in, right? You know what weapon you want to choose. You might even have a kit picked out. You know what parts you're going to use. But how do you get plugged into the community? Because the robot combat community is often one of the most overlooked things when it comes to this. The people are just fantastic. No, everyone's there to have a good time and see some robot fights. So everyone wants to see you succeed. That's the end of the story. So you find events. There are two different websites. One is Robot Combat Events. That's the bigger website. Builder's Database is kind of like a version 2 of like the original robot event site. It's pretty cool if you want to run an event on there. They also have their own bracketing system that you can just take the registered bots and put them right into a bracket, as opposed to just having another bracketing software and then just manually typing in the names from there. But these are the two websites that you want. Like between these two websites are all of the events in North America. Some even in Australia and England use this use these websites as well. So this is the National Havoc Robot League. This is just a screen cap of their website, nhrl.io. Again, competitions, they have a very prevalent YouTube presence. They live stream every event. It's a very doctored up production, but they still let the fighters fight, which that is one of the best things. They're based out of Norwalk, Connecticut. They have, again, just 3 pounds, 12 pounds, and 30-pound fight. They don't have any intention of doing any like the 1 pound weight classes or any of that. This is something that maybe you would want to compete locally first and then work towards competing here. This is the event where I mentioned earlier, they consistently have 200 plus robot events and they get through it in one day. It's actually pretty amazing. So this is probably the league you might want to start since we're all in New Jersey. I don't know where you guys are from, but the Garden State Combat Robotics League, I'm actually blessed to be a board member of the league. We are actually running an event in conjunction with the Trend Computer Festival today. It'll be going on. They're going on right now. Probably be going to like 5:30, 6 o'clock-ish. If you guys want to stop by the Broward Student Center. Fights will be going on all day. We have fights going on all around New Jersey and mostly North Jersey. We have this event in Ewing. We had an event in Mount Laurel a couple months ago, down more a little bit south. But this is, we have competitors come all over the Northeast to come compete with us. So these are a couple of the Discord communities you can get plugged into. This is where most of the builders share their ideas, ask for advice. The one on the left is the G-Scroll. That's what we call the abbreviation, the G-Scroll Discord. And then on the right is the NHRL Discord. Both extremely good resources if you want to get connected with builders and all of that. Does anyone else want to scan before I move out? I'll also have a resource page linked at the end. It'll have links to all of these. Here are a couple of the Facebook pages. There's just the general Combat Robotics page, as well as the ant weight and the beetle weight page. Just pretty basic open forum type stuff. Pretty run of the mill there. So this is the link that you would really want to get. This is the Garden State Combat Robotics League official resource page. This has links to all of the websites that have the parts, the kits, where you register, how to build, tips and tricks. If you can think, if it's a question and you can think about it, Combat Robotics, the answer is most likely here. I'll leave that up for a little bit. Make sure everything's going to be awesome. All right. Anyone still scanning? Good. Good. All right. So have a little bit of time left. So I'll go through this a little bit quickly. That way we can have time for questions at the end if you guys would like. So this is just like a basic walkthrough of like a day in the life of your first competition as a combat robotics builder. So what do you need to pack? Basically, I like my toolbox, I bring assorted screwdrivers because especially with these little ones, you don't know which ones you need a pry bar for. Appropriate sized Allen keys. Usually most of the kits and stuff will come with their own Allen keys and hardware, so you don't have to worry about purchasing that separately. Drill and drill bits, Dremel cutoff wheels, a magnetic bowl. I love my magnetic bowl. Don't lose any of the hardware with the robot, just stays right in there. A workspace pad just to keep, because a lot of the times the tables are often provided by the venue the competition is at. So you just want to make sure all the goodwill stays there. Soldering iron in case you need to replace any electronics. And then a LiPo charger, and then a lithium polymer charging bag to prevent any fires if needed. So that was what to pack tool wise. So this is what to parts, spare parts wise. Spare parts is more of a philosophy and depends on what kind of robot you have. But my general philosophy is at least one spare of anything electronic related. So whether it be a drive ESC, a BEC, a weapon ESC, right? One of those spare, that's normally enough because those aren't normally taking the impacts, but I would have at least two spares of anything mechanical. So drive motors, weapon motors, anything specialty wise you need, you want at least two of them. And then at least one spare battery. That way you can have the battery charged and waiting for you after your fight. If nothing happened, flew for your first fight, breeze, easy. I know you guys will. That way, all you can have to do, unscrew the top, take the battery out, put it on the charger, take the charged battery, put it in, you're all set to go for your next fight, and you'll make your event organizers extremely happy. So what time do you normally want to get to an event? The events will have a standard time on the event page. Just leave yourself a little bit of cushion. You don't know. Gremlins usually get into my robots and mess something up the night before. So I'm always going through issues at the event. So just leave a little bit of time. You don't want to be rushed, and just don't sweat it. Just make sure you're getting there a little bit early, just to make sure that the event can still run smoothly and you'll be all right. So safety and check-in. Each robot is required to go through a standardized safety process as part of the check-in to actually get your robot onto the bracket. So all events require a transmitter and receiver fail-safe. So that means if worst comes to worst, the robot loses a radio signal, everything turns off. That way there's no way the weapon can keep spinning, wheels can keep turning, anything like that while a robot has lost radio signal. They also require a weapon lock for an active weapon to prevent it from spinning, as well as the master power key that I mentioned earlier. And then each event kind of handles like the process differently. Some will have you pay the registration fee, then go through safety, and some events will just have you fill out paperwork, have you sign. Everyone will be extremely forgiving and considerate, and you'll be 100% good to go. So what happens before your first fight? So I usually like to just take a complete full robot inspection, make sure spinny things are spinning as needed, nothing's rubbing. And then you just load into the arena, the usual load in process. You load one robot at a time. That way there's never more than one person in with a robot on at once. So you load the robot in, you turn your transmitter on. That way, as soon as the robot turns on, it receives a signal. Turn the transmitter on, put the transmitter down, turn the robot on, and then you remove the weapon lock. Removing the weapon lock is the last thing you want to do. And then just wait for the countdown and go at them. You got 2.5, 3 minutes to make your cases to the judges, and you'll be all good to go. So if you guys obviously dominate your first fight, no damage at all whatsoever, you still have to unload. So I know you guys will be able, but I have to say it anyway. If you're able, drive back to just where you started, whether that be the arena door, starting square, whatever. then you unload your robot. So unloading process is basically the same thing as load in process, except reversed. So this time weapon lock goes on first, then robot goes off, and then transmitter turns off. And then just take your robot back to the pits, assess damage, charge batteries, anything like that. So now that went through that presentation, have any questions? Any questions at all, honestly?
Did you say there's an event here?
There is an event here. It'll be running, it started at around 11 and it'll be running until 5:36. So, and then, yes.
Are there any autonomous robot fights kicking off yet?
There are, so there used to be a autonomous weight class, but it wasn't extremely popular. People that did it really liked it. However, it was just extremely hard to have the robot be effective and still fit in the weight classes. So they used to have an autonomous 1 pound and an autonomous 3 pound. Plus, it's kind of tricky to fail safe those things because there has to be some kind of way to turn those robots off without going into the arena with active robots. There are robots that have coding elements, like there are a couple on BattleBots, like a hammer that had an optical sensor in front of it, would sense when the opponent wasn't within striking range, and then automatically fire the hammer, so that they could do that. But yeah, yes.
You mentioned the LiPo bag. Does that mean you can charge your batteries, sort of fire?
Yeah, yeah, that's.
What is that like?
It's not really that that complete. It's just put in the LiPo bag, and it's a fireproof bag, but it's not a airtight bag. So it's basically to prevent like a big outburst of flame that could catch other things on fire. Yeah, Kevlar or something like that. You can get one off Amazon for like $20 or something. Yeah, not too much. Any other questions?